Greetings, wonderful people. This is Mr. Ndabezita once again, and this time we will be looking at a brand new chapter of exception handling. So what we will do, we will just create a new project, and it will be a console application, and this is what we will have, and we will just call this let me check, miles per gallon. So we will call this miles per gallon. Very important. And then we will press on the next, and we will try by all means. Okay, let me just create. All right, and then just to give us a brief summary of what we will be doing here is the fact that an exception is any error, condition, or unexpected behavior in an executing program. So you are trying to execute your program, and then a certain unexpected behavior transpires. This is what we call an exception. So it is an error condition. It's an error condition by the time you are trying to debug your problem, and then it's just unexpectedly throws out an error or behaves in a way that you did not expect, and then as a result of that it throws an exception. Exceptions occur because of errors in a program logic or because of insufficient system resources. These are some of the definitions that we get from the textbook, which is true. Right, the program you write can generate many types of potential exceptions, including your program asks for a user input, but the user enters an invalid data. Because of this invalid data that the user enters, there can be an exception that is thrown. There can be this error condition that you did not expect. Or the program attempts to divide an integer by 0. Suppose I say enter two integers and the first integer it's a whole number, the second one it's a 0. So division by 0 will also cause an exception. Or when you attempt to access an array with a subscript that is too large or too small, there can be an exception that is happening. So these are just the bulleting that gives us an inside view as to the conditions that might result in an error being thrown, an exception being thrown, an error condition, or unexpected behavior in an executing program. You are trying to execute a program and these errors now suddenly reveals themselves. You calculate a value that is too large for the answer's variable type. So you are calculating, and then the answer that you are getting, you are trying to store that answer inside a variable that cannot contain such a huge amount of value, and as a consequence of this, an error will be thrown. Very important. These errors are called exceptions because presumably they are not usually occurrences, they are exceptional. So they are not usual occurrences, they are exceptional. The object-oriented techniques used to manage such errors makes up the group of methods known as exception handling. So when we deal with object-oriented programming, we will see the difference between the traditional way of handling errors and the object-oriented techniques of managing such errors. If you do not handle an exception, the running program terminates abruptly, and then it will give you the conditions that has led to that particular condition. In C#, all exceptions are objects that are instances of the exception class or one of its derived class. This is very important, that in C# all the exceptions are objects. They are objects that are instances of the exception class. Very good. Or one of its derived classes. An exception condition generates an object that encapsulates information about the error. Like all other classes in the C# programming language, the exception class is a descendant of the object class. Very important. The exception class has several descendants classes of its own, many with unusual names and so on and so on. We will not go into the details. So the very first thing that we will do, we will just get rid of this. And then once we have got rid of that, let me do the following. Let me just take this laptop a little bit higher. There it is. There it is. Very, very good. All right. One thing that we will do when we are here is to create a namespace, and we will call this X as we always do. We will create a class and we will call this P, and we will have a static. It will be void, and we will call this the main string of array arguments, and then here we are. So we are having this end main, we have end the class, and we have our end namespace. Okay, the spelling is not so important. Now the most important things that we need to look at, the very most important things that we need to note, is the fact that we will create a class. Very important. So I will just come here and let me just place things in a nicely order before we can continue with this. Let me just try to place things in an orderly pattern so that I may give you all the necessary food for the day. Right, now everything has been placed well. Here it is. Right, so I'm a left-handed person. I need to place things in the side that will be on my advantage. Now we are fine. We are very much fine. So the very first thing that we will do, we will just create a class add, and we will add a new item, and this new item we will call a, okay, let me just do this. We will call this, let me look at the namespace so that I don't make mistakes. Okay, so we will call this miles per gallon. Very important, and it is a class, and immediately the class is created for us so that we may be able to work inside of it. So what is it that we are going to do here? And what we are going to do, they say you can deliberately generate a system exception by forcing a program to contain an error. Very good. As an example, in every programming language, it is illegal to divide an integer by 0 because the operation is mathematically undefined. Okay, that is fine. So we are inside of this class, the miles per gallon class, and we will declare some few things. But before we deal with the declaration, I will end the main or the class. Sorry, I will just end the class, and I will also end the namespace. That is fine. So I will have some few variables in this class. First one will be an int, and it will be miles driven, and I will assign them no value. I will have the second one, I will have gallons of gas. So let me just say gallons of gas. Very good. And then from there I will have an int which I will call the mpg. So the first thing that I will have is a write statement. So I will just import static system.console. So the first thing that I will do, I will just import that so that I don't have to continue typing console and so on. So I can just have a write here. Sorry, I'm in a class. I'm very sorry. So one thing that I will do inside of in fact I don't even need a class. In fact, I don't even need a class to demonstrate this. I can just cut this. Forgive me for creating this class. I don't need this class. I just have to go to the main and let me just paste whatever there is. Very good. So one thing I can do when I'm here, let me just have using static system dot console. Right, and then when I am in here, the very first thing I will do, I will just have a write statement where I will say just enter miles driven, and then the individual will enter the miles given. Then I know that those miles driven will be saved inside of a container. Miles driven equals convert dot to int 32, and then I will just have console dot read line. So I will just have a read line there. Right, I will just have this read line. So I'm just saying convert dot to int 32, and then I am reading what this individual is trying to input. Okay, that is fine. No problem with that. And then I can just go here, and then what I can do, I can have another prompt. And in this second prompt, what I can say is just enter the gallons of gas purchased, and the individual will enter that, and then I will save inside of gallons of gas equals convert dot to int 32, and then I will just have this read line. Very important. And then from there, what I can do, I can say okay, mpg miles per gallon, the abbreviated form is equals to miles driven divided by the gallons of gas. This is the performance that I want, and then from there I can just have a write line, and I can just say you got, and I'm going to use placeholders, you got 0 miles per gallon, and then I can just have mpg, and everything is fine. Everything seems to be very well. So let us try to run this code and see exactly what is going to happen. So now I will just press Ctrl F5. And let's just wait for the compiler to finish up. Right, here we are, enter miles driven. Let's say the miles driven, for example, it's 300. Enter the gallons of gas purchased. Let's just say maybe it's 12. And then you got 25 miles per gallon. There's no problem with this. Everything is working fine. Now let's run this once again. This time I'm going to enter 300 and then enter the gallons of gas purchased, and I'm going to enter a 0. And when you press enter, we have an exception. Unhandled exception. There was an exception, there was an error, an unexpected behavior, and you did not handle this exception. Now, what is this unhandled exception? It is a system.divide by 0 exception. Attempted to divide by 0. So you attempted to divide by 0, which is true, and when you do that, there is an exception that will be thrown, and it is a system.divide by 0 exception. Very, very important. And it tells us in which line the error occurred, in line 15. So let's go and look at line 15. There it is. In line 15, the gallons, the number that you are attempting to divide by, it's 0. So in this line 15, the gallons is 0, therefore an error will be thrown. This is just something that they are trying to explain to us. Right. In the first execution of miles per gallon program, the user entered 2 usable integers. That's exactly what we did. We entered 2 usable integers, and division was carried out successfully. In the first program, we saw that the division was carried out successfully. Very good. However, in the second execution, the user entered 0 for gallons of gas. This is exactly what we have done. And the error message indicates that an unhandled exception named system.divide by 0 exception was created. We saw that. The message gives further information, and then we saw that it said attempted to divide by 0, and shows the method where the exception occurred. We saw that it occurred in miles per gallon dot main, and we saw that we were trying to divide by 0, and that was in line 15. That is fine. That is fine. That is fine. No problem with this. Is there a better way of which we can look at this? Now let's go and understand the traditional and the object-oriented error handling methods. So we will look at the traditional way of handling errors and the object-oriented way of handling these errors. Right, they say programmers had to deal with errors conditions long before object-oriented methods were conceived. For example, dividing by 0 is an avoidable error for which programmers always had to plan. So this was the traditional way of looking at things. They always had to keep it in their minds that division by 0 causes an error. So they had to always ensure that in their program, this type of error is always avoided. There was no way through which maybe the object-oriented way of dealing with this. Let me put it in that way. If you simply check a variable value with an if statement before attempting to divide it into another number, you can prevent the creation of an exception object. This is true. That's one possibility of what we can do or what we could have done. Okay, so what they are doing or what they are saying is just simply the following. So now remember, we entered a value miles driven. We know that the numerator cannot throw out an error, because if the numerator is a 0 and any number divided, a 0 divided by any number is 0. So we are not focusing on the first value that is entered. But we know that division by 0, it's a complex number. It is unacceptable in mathematics and also in software engineering. So we are concentrating on the second number that needs to be entered. So we can say once the gallons have been entered and we have received that, before we can divide like this, we can run a check. We can say if gallons, if the gallons are not equals to 0, then we can say, if the gallons are not equals to 0, therefore we can carry out this functionality. This is one thing that we can say. We can say if this is true, therefore the miles per gallon is equals to miles driven divided by the gallons of gas. This is what we can say. This will be the if statement. We can also have an else, and then in our else statement we can say the miles per gallon mpg is equals to 0. This could be the else part. So what are we saying here? We are saying, now once I have received the gallons of gas, I want to run a test first. If these gallons are not equals to 0, if the user did not input a 0, go on and carry the calculation. Else, if he inputs a 0, just make the miles per gallon calculation here be equals to 0. This is exactly what we are saying. And then it will go to this line and then it will say you got 0 miles per gallon. Let's try and check if this can work out for us, and we can just try to avoid this error. Let us try to look at this. So enter the miles driven. I will enter 300, and then I'm going to enter 12, and we have 25. Everything is fine. Now let me go. I will enter 300, and now I will enter a 0, and you got 0 miles per gallon. You see, so the error was handled in a traditional way, because I did not use object-oriented programming. I did not use the object of the exception class to be able to find the error and retrieve a message for me. This is the traditional way of looking at this. Please, we need to understand that. Okay, that is fine. That is fine. I think we have understood that. That was a very simple way. So now let's go and understand the object-oriented exception handling method. Now let me just go for a cup of tea and I will be back. So let us continue with our study. So we are trying to understand the object-oriented exception handling methods. In object-oriented terminology, you try a procedure that may not complete correctly. Very important. In object-oriented terminology, you try a procedure that may not complete correctly. A method that detects an error condition or exception throws an exception, and the block of code that processes the error catches the exception. Very important. A method that detects an error condition or exception throws an exception, and the block of code that processes the error catches the exception. In object-oriented terminology, you try a procedure that may not complete correctly. So that is to say, you insert inside of your curly braces the method that may result in an error inside a try block, and then the catch block catches the error and throws an exception, and then you will have a condition or a message as to that. This is the object-oriented way of approach, in contrast to the traditional way of looking at this. When you write a block of code in which something can go wrong, you can place the code in a try block. If we are compiling a code and we know that something might go wrong when this happens, then we take that block of code and we insert it inside a try block, which consists of the following elements. The keyword try, it is a reserved keyword try. A pair of curly braces containing statements that might cause an exception. This is very true. Inside of the try block, we will have that condition that we assumed, or we think, or we know, or we speculate, or we suspect that it might throw an error. You must code at least one catch block or finally block immediately following a try block. So whether you like this or not, once you have inserted your code inside of a try block, when you exit the try block, you must have a catch block, at least one catch block or a finally block. Each catch block can catch one type of exception, so you cannot have multiple exceptions in one catch. Each catch block can catch one type of exception. You create a catch block by typing whatever. Okay, that is fine. Now, suppose in this miles per gallon that we have been working on, let's get rid of this traditional way of looking at things. Now, I know that there is a possibility that when this is happening, in fact, let me go back to the calculation. MPG is equals to the miles divided by gallons. Okay, this is fine. I know that when this is happening, there is a possibility that there might be an error that is thrown here during the output. So what I'm going to do, I'm going to insert this calculation inside a try block. You say try, and they said you insert the code that might generate an error inside of a try block. So I'm going to cut this and paste that. There's a possibility that this might throw an error, and immediately when I exit the try block, I can have a catch or a finally block. So what is it that I am catching? Very important. What is it that I am catching? Right. What I'm trying to catch is the error that might result when that is happening. In fact, I can enter the entire thing. Cut. In fact, let me not enter the entire thing first, so that I can show you something. Let's just leave that. Right. In the catch, what is it that I'm catching? I'm catching an exception. Remember, this is a class, an object. And then I can just say the letter is E here. I know that it will throw an exception, an object, and then I am assigning a variable of that object as G. Right, that is fine. So I am trying to do what? I am trying to catch this exception. Right. And then I will create my two curly braces. Then I am saying the miles per gallon. The first thing, MPG miles per gallon is equals to 0. When there's an error that is happening in here, please catch an exception and assign 0 to the miles per gallon calculation. That's exactly what I'm doing. And then immediately after that, I can have a right line. I can have a statement that tells the user who interacts with the problem exactly where the problem is. Now I can say to this individual, you attempted to divide by 0. This is the message that I'm throwing, that you attempted to divide by 0. And then after that, I am giving the individual the calculation that is required. So remember, this is an exception, and we read about this. Let me just refresh your memory a little bit. We said now, we said, okay, let me just check for you. We said in C# all exceptions are objects. What is this now? This is an object. Very important. We said now in C# all exceptions are objects that are instances of the exception class. So this is an exception class. Very important, and it is an object or one of its derived classes. An exception condition generates an object that encapsulates information about the error. It generates an object that encapsulates an information about the error. Here it is. This is the object that encapsulates an information containing the error, the information about this error that has transpired. An exception condition generates an object that encapsulates information about the error. Very important. So let me try to run this. I want to show you something. So I will enter a number 300 and I will enter a 0, and you attempted to divide by 0. The error was catched. Let me show you something. The error was catched here, and you attempted to divide by 0. And then it went to the next line of code. You got 0 miles per gallon. Now let me show you something again. Let's run this. Suppose the user now enters, instead of entering a number, the user enters H. Now we have a problem. Input string was not in the correct format. So it is therefore important that we enter the whole thing inside of a try block. Very, very important. Right. Let's try to run this for the second time. Enter miles driven. Let me just say 45. Enter gallons of gas purchased, and I will enter a 0, and it was handled. All right, that's fine. Now let me enter P now. You attempted to divide by 0. You got 0 miles per gallon, and I did not divide by 0. But because the input string was not in the correct format, okay, you did not, this is not a suitable exception that needs to be handled. But let's just leave that. That is fine. I was just trying to show you the try and the catch block so that you understand exactly what is happening there. Okay, that is fine, no problem with that. So we saw the try, and we also saw how the catch might work. All right, now we are going to use the exception class to string method and message property. Very, very important. Now, still on this, Now I saw that when I ran this code and I said enter miles driven and I enter U, this is not the correct message that needed to be displayed. I was never attempting to divide by 0. So how can we solve this? Now, during the catch, I need to find a message that matches exactly the error that I have done. And in that way, I am going to say catch an exception that I have, which is exception E. Nothing is going to change. And then when I am here on the right line now, this is what I'm going to do. When I am in this right line, this is what I'm going to do. I'm now going to say E using the object E dot, and then I'm going to say to string. And then remember, to string is a method. Remember, this is a method that accepts no argument. So by doing that, let us try to see exactly what is going to happen. In fact, let me read you some few notes. When the miles per gallon program that we have written displays the error message you attempted to divide by 0, you actually cannot confirm from the message that division by 0 was the source of the error. We saw that. When we ran this, we saw that division by 0 was not the source of the error because we never attempted to divide by 0. We just entered an alphabet and then the wrong message was displayed to us that we attempted to divide by 0. So the error did not match exactly what we have typed. In reality, any exception generated within the try block of the program would be caught by the catch block in the method because the argument in the catch block is an exception. This is true. Instead of writing your own message, you can use the toString method that every exception inherits from the object class. This is very important. Instead of writing your own messages, hence I have deleted that message that I have written, which was my own message, you can use the toString method that every exception inherits from the object class. This method, it inherits this method from the exception class. Very important. The exception class overrides the toString to provide a description, a descriptive error message. So the exception will override this message. It will override this method. And then what it will do, the exception class overrides the toString method to provide a descriptive error message so a user can receive a precise information about the nature of an exception that is thrown. So what is going to happen here, the exception class will override the toString and then it will provide you with the message that matches exactly the description of your error. This is exactly what will happen. Now let us try to run this and check if this is true. And then let me enter this value and then let me just enter an H and press enter. System.format exception. You see, input was not in the correct method format. Man. So this is very true. So what has happened here? Based on the explanation that we have just read. Right. I have an object here and then I'm saying this object, the variable of this exception, which is E, this object, E.toString. Right, the .toString. What is going to happen here? The exception is going to override this method. And then it will give a clear description of what caused the error. And because I inserted an alphabet H here, now system.format exception, input string was not in the correct format. this is the cause of the error. And I know this is true because I had to insert an integer and I did not do that. I inserted an age. So by saying write line e dot to string, I am overriding this method, and then the exception will provide inside of this dot to string the correct method or the correct description of what caused an error. Very, very important stuff that we should never and ever forget. Never and ever forget. Right, that is fine. We read using the exception class dot to string method and the message property. Now let us go and look at the message property, exactly what the message property will do. The exception class also contains a read-only property named the message that contains useful information about an exception. So they say the exception class also contains a read-only. It's a read-only. You can read from that, you cannot write to it. The exception class contains a read-only property. We know we dealt with properties. They have a get and a set. So that is simply to say you can read from that, you can get, and then you cannot set. Right. The exception class contains a read-only property named message that contains useful information about the exception. Okay, let's go and use that and see whether it will also work to our advantage. So I can just say here dot message. Right, and it is a property. Very important. It's not a method, it's a property. Right. And then let's run this and check whether it will also provide us with some useful information. I will enter U, and input string was not in a correct format. So this one gives you a brief, just a straightforward information. So the dot to string gives you a long thing and tells you so many things, but this one goes straight to the point. Input string was not in the correct format, and then that's it. So let's just investigate the difference again. So let's just say here dot to string, and it is a method, I know. Just close that, run this, and check what is going to transpire. And then I enter an H. You see, this one provides so much information so that you may know exactly what is happening. First of all, it is a system.format exception. Input string was not in the correct format. System.number.throw, overflow, or format exception, passing, whatever, that is fine. And then it also tells you this one where the error occurred. The error occurred in line 15, so that you can go to line 15 and correct that error. So this one, it's a more descriptive way of helping us, whereas this one, you never know where the error has occurred. You never and ever knows where the error occurred. You never and ever know. So these are the differences that we should note. This one, input string was not in the correct format. It provides you with nothing as to a detailed descriptive way of knowing where the error is, and then you can be able to correct that error. So this one I will not recommend when you are writing a very lengthy code with inheritance and everything. This is not a descriptive way of showing you where the problem is, but it is a straightforward way of showing what is happening. Okay, this is fine. We have had a close to 45 minutes lecture for today, so I think I should just cut it here, guys, and then when we continue we will build on this, and then we will carry on forward, because there are a lot of things that we still need to deal with when it comes to the exceptions. So I'm very grateful. Please don't forget to like, share, and subscribe. This is Papa Fanzo, the great mathematician.